Electromagnetic radiation is a phenomenon of nature. It's emitted from the sun in waves of all different lengths, from the smallest waves possible to very, very long radio waves.
Now, are we talking waves like you see in the ocean? Is it the same type of thing?
Very similar, yes. We're talking waves, but they're not waves of water or waves of mass, which is a very good question. They are waves of electromagnetic fields. It is a wave of fields, which is difficult to understand. But when you get a little older,
okay.
No, it's a wave of fields. That's right, and it goes through space. They travel through space.
Now, where do they come from?
Good question. You can generate electromagnetic waves, and we'll be doing that in just a moment. But in nature, they come from the sun, among other places. And almost all matter can emit some radiation. All right, let's just say this is the sun. Okay. Now, to understand waves a little bit, I'm going to ask you a couple of questions. Let's say we had the first wave coming off like this. All right, let's call that wave A.
Okay.
And then the next wave, let's say it looks like this. We call this wave B.
Okay.
Now, first tough question. Which wave, A or B, has a longer wavelength? Has a longer length of wave?
This one I actually do remember.
Okay.
It's A.
All right, good. You learned well in school. Of course, it's A, because it's got a long wavelength compared to B. But, now here's the tricky one. Which one has a higher frequency of waves, A or B?
I think, if I remember correctly, I don't know for sure, I think it's B.
Of course, it's B, because, you see, there's more waves per unit distance. That is a higher frequency of waves. And that relates directly to what we're going to be doing today, because one of the experiments that we're going to be doing involves a radio, where when you adjust a radio, what do you adjust it to?
Well, now that's what I was going to ask you.
Yeah.
When you said frequency, I noticed frequency modulation on my radio.
Exactly, VFM band. So what you're doing when you adjust the radio, you are adjusting it to different frequencies. That is, different frequencies of waves.
I see.
You see? Now, the first activity...
Okay, I'll hold on to this here.
The first activity that we're going to be doing requires kids to make their own electromagnetic generator. They get to actually generate electromagnetic waves.
And you can do that with just a battery?
Just a battery.
Wow.
What you do is the kids just tape a wire to either end of the battery, and they can tap into that energy of the battery, and when they complete the circuit by hitting the tines of the fork, it excites the molecules in the fork, which vibrate back and forth, which send out that wave. Remember, now this is what electromagnetic waves and sound waves have in common. At the source of that wave is a vibration. Here, it's molecules vibrating back and forth that are sending out ripples of the electromagnetic waves around them.
Now, you have that hooked up, and when you brushed it across there to demonstrate, I didn't hear anything, except just the wire going across the fork.
Very good. Well, let's see if we can do an experiment to see if actually we are generating electromagnetic waves. Why don't you go ahead and turn that radio on?
All right.
Yeah, put up the antenna. Is it on an AM frequency?
It is indeed, yes.
Okay, now listen to this. See if you hear anything here.
I did hear that.
You hear that? Okay.
It almost sounds like you're scraping it across the radio.
Yeah, it does. What's happening here is, again, the electrons and the atoms are being excited, emitting an electromagnetic wave. It's being picked up by the antenna, traveling down. And remember the speaker activity we did? Okay, we've got a speaker in here that turns the radio wave, the electronic impulses of the radio wave, into a physical sound wave. And that's what we're hearing here.
Okay, so just by the power that's being emitted from connecting the wire to the fork, that is creating all of that sound.
Well, it is. In fact, there is an amplifier in here. That's a good point. It amplifies the wave to help turn it into that sound wave. But yes, it's starting off with this wave, picking it up, and turning it into a sound wave. So it's taking an electromagnetic wave, turning it into a sound wave so we can hear it.